Hello, everyone. Welcome back. I'm happy to see that we still have people attending the conference. We're almost at the end of JCON 2025. This is the third day, unless you were here for the workshops. Anyone here for the workshops on day 0? Oh, that's great to see so many hands. Great. So as with every other session, please feel free to send your questions to Slido, and I will answer the questions at the end. Also, if you feel like raising your hand or asking any questions at any point during the presentation, please do so. Okay, so today we're going to talk about, like everybody else, is AI. AI is in everybody's mouth. And I want to showcase a few things on how we can actually put this to work. So my name is, what happened with my slides? There we go. Yes, so my name is Almiray. I'm a Senior Principal Product Manager for Oracle, although I like to call myself a seasoned sorcerer because I like to work with open source code. So I've been doing this for quite some time. I mean, doing open source for close to 20 years, and I've been doing Java since 30. I'm one of those. I'm a test containers champion and I'm a Java champion alumni. I like to talk about these things. So if we didn't have a time restriction, I will have you here for a few hours. So we're here because we love Java and we are Java developers, but also because AI now appears to be everywhere. So a few things. So what is it? Well, there's basically actually nothing new. AI is just the next iteration of the technology that we keep using. So who remembers what was the previous, let's say, love heart of the BC money? Blockchain, right? And before that was machine learning. And before that was deep learning. And before that, grid computing. So we were just doing these kind of things. We're just building what we understand now as AI, LLMs, is the rebranding of the previous shell, which was machine learning, which is pattern matching on asteroids. And before that was deep learning, which is how we can much easily use neural networks to get to resolve particular problems. So what we have today is yet another thing, another shell on top of this thing. So it's very likely that, I don't know, 3 or 4 or 5 years from now, we'll have yet another bubble on top of this, maybe called AI as well, but it will be something completely different from LLMs. In case that you're interested in doing deep learning in Java, there is a JSR, a standalone one, so it doesn't come with the standard JDK that you download from any JDK vendors. There is a reference implementation for this, which I believe by default is applicable to video encoding and image recognition, but you can certainly make use of this particular library in case that you have to use deep learning. Now, that's the kind of the what. Now we go into the scary issue, which is the why. Why should we be using, or why should we be doing AI? Well, basically, because of this. Because there's one person at the top floor that's saying, everybody's doing AI. We should be doing AI. We are going to do AI. We're going to add AI to our products. I don't know what it is. I don't understand it. I don't know how you can eat it. I want it now. I want it from yesterday. You guys have to do it now, isn't it? Sounds familiar? I hope not. But for some people, this is the truth. Now, yes, this has been happening, but here I want to showcase another reason why it would be a good idea to do these things, not just because, hey, it's cool and it's hype. So this video came out in February, I think, early February. And this is from a channel called Veritasium, and Derek is a nice educator. So what happened in this particular video is the following thing. In the realm of chemistry and bioinformatics, I think this was in the 70s, late 70s, early 80s, there were a couple of scientists that wanted to understand how the biological proteins, the molecules of the proteins will fold. And by folding, it means how the different atoms arrange themselves in 3D space, which is depending on if they're twisted, if they are in a particular position, and if how the electromagnetic charges will work, then the proteins will have certain capabilities, will offer certain behavior, or actually well, I don't know exactly what I'm saying. I'm translating software into bioinformatics. So they will offer, they will combine in certain way that will give you exactly the things that you're expecting for. So the first time that someone was able to determine how a given protein was folded, they had to use microscopes and do everything by hand. It took forever, but they made it happen. Once they have a process, they repeat it for the next protein, and again, it took months. And then they streamlined this, and it took weeks. But it took a long time for each one of those. And there's a vast amount of proteins in the natural world. So they will not be able to do this as fast as possible to get all the benefits. So at some point, someone decided, hey, can we just do this with computers? Could we just create a program that would do a prediction of how a particular protein will fold? Okay, so they went to do that, and it turns out that the accuracy of the prediction wasn't that good. It was in like in 10% or 20%, which is not really that good. They needed to reach until close to 90% to say something like, yeah, we kind of can't trust this thing. So it took years and years and years. There was a contest to make this work. So I'm making sure what is discussed in this video, which I recommend you to watch. To a point when I think it was 7 or 8 years ago, someone created an AI power program, we're talking about machine learning at the time. So this was not LLMs, called AlphaFold, which was able to go above 90% confidence of the predictions. Since then, so by the time that AlphaFold was still in development, they had a few hundred proteins, or maybe it was a couple of thousands. Once AlphaFold reached out past the threshold of 90%, they were able to map 2 billion proteins, pretty much every single one in existence. Not only that, they were able to create new synthetic proteins based on the predictions of AlphaFold. So the benefits and advantages of using AI in science are undeniable. Whether we call this LLMs or machine learning or live learning, it doesn't matter. The way that we can use computer power that was really not that good some decades ago, and what we have right now, it's definitely something undeniable. And we, as developers, we can help in this space. We can do it in bioinformatics, we can do it in chemistry, we could create or we can predict new materials. So there are many, many things that we could do in this regard, and not just creating chatbots. Although most people nowadays are kind of interested in chatbots. So when should we be doing these kind of things? Well, if you ask me, right after you finish this session. Because the best time to start something was yesterday. And the next best time is right now. So when are you going to do AI? As soon as you finish this thing. In terms of who is doing it, well, I want to showcase 2 major players in the Java ecosystem. You may be aware of this already. One of them is Spring AI, who uses Spring technologies. Okay, like, wow, 70% of the audience, which is what I expected. So Spring technologies are pretty much the king of the hill in the Java space. So obviously, they offer a set of abstractions that can do many things. They can talk to chat models. They can do, obviously, GenAI. And they offer the same way of, the same programming model that you're used to in terms of Spring technologies and Spring applications. So if you already know how to do a Spring Boot applications and do a Spring Data and Spring Batch and all those other projects, then jumping into Spring AI is not that difficult. Now, they have plenty of documentation. And one of the things that when I was preparing this session like 2 months ago, the speed of the rate of development of Spring AI increased such that I've been using Spring technology since 22, since before Spring Framework became 1.0. So I kind of know Spring. And I know the way of working with the Spring, even with the latest fashions. But given that this API was so recent, of course, I will have the chance of ask a copilot to help me create an example. But the thing is that I wasn't sure that the suggestions provided by the copilot will be accurate. Why? Because the model very likely was not trained with the data of the latest API for Spring AI. It would probably have given me, if anything, a few versions behind. So the demo would not be properly accurate, but I wouldn't be able to tell because I kind of know Spring. So the solutions proposed by the Copilot will be like, yeah, it looks okay-ish. So it wouldn't have been the best possible example. So for that reason, I want to showcase the other possibility, which is LangChain4j, which, by the way, just yesterday, they announced version 1.0.0. Spring AI is in 1.0.0 release candidate 1, also announced yesterday or 2 days ago. And it's been known that their schedule will post 1.0.0, the final release, next Tuesday on May 20th. So it's pretty much upon us. So these two frameworks, these two technologies are pretty much neck and neck. LangChain4j, you can use it on its own, standalone, or you may want to combine it with Quarkus or Spring or some other frameworks. It's quite common nowadays that when someone talks about LangChain4j, they will simply show you, hey, here's how I can create a Quarkus application and then add LangChain4j. And I'm not going to do that today. I want to showcase it specifically on just the library, on just the framework. So if you want to combine it with Quarkus, that's good. If you want to combine it with Jakarta EE or something else, that's also perfect. We're going to show only LangChain4j. One thing that I like about LangChain4j is that the library of examples is quite extensive. There is a repository known LangChain4j examples. So this is a screenshot from 2 months ago, or close to 3 months ago. So I'm pretty sure that this has been updated to the latest versions, to 1.0. So if there is a particular concept that you're looking for on how to implement with LangChain4j, there's bound to be an example there. And these examples are pretty much self-contained. That is, it's just one file or one small set of files where you can understand the whole thing. Whereas if I were to showcase with Quarkus or Spring or other framework, then I will have to show you, well, here's the bean that goes there, another thing, another component, and things go all over the place to please the framework instead of understanding the concept itself. So I would recommend you to have a look at these ones, understand the concept, really grasp what is explaining in that particular example, and then you decide how you can map the different components into the places where the framework will require you to do things. So how? Well, as you may be aware, the LLMs are models that usually come pre-trained on a vast amount of data. We can debate the ethics of where that data is coming from and how it was obtained and all that. But the fact is that those things exist. And these models are constantly being retrained with more data. Well, we cannot be sure what is the data set and if it will contain something that is germane or pertains to our customers. I mean, it would be kind of great if we can ask an LLM about all the data that we required, but it will be kind of like risky if that contains private data from our customers or our own private data, isn't it? So we are not able to just use any LLM and simply ask the questions and have the answers that we expect to be answered correctly. On the other hand, in order to do that, we will have to train our own models, and this is computationally expensive on the one side, and you have to spend a lot of energy on it, so you have to spend a lot of money. Now, there are a few companies in the world that will be able to do this, so for this reason, most of them will consume a pre-trained model. But we still have to find a way to have those models have access to our private data in such a way that we don't leak that data to the outside world and someone else can have access to. Or that we can keep supplying a new flow, a new stream of data as it's coming from our customers, right? So this is known as RAG, Retrieval Augmented Generation. This is how it works. So you create an application where you will supply a prompt and a query, whether it is a user query and assistant query, so you can tell, this is the question I want you to answer, and I can tell you this in the system query, and I want these additional parameters so that you will be able, the chatbot will be able to understand more what you want to do. And before the question is sent to LLM, which is almost the last step in this case, we will retrieve your private data. Now, that data is not taken as is. It's not a bunch of HTMLs and text files, PDFs or what have you, images, video. It can come in many fashions. we actually have to grab that data in a particular format. It has to be encoded in some format. That format is a set of numbers, which are known as vectors. Now, the trick here is that these vectors can have many dimensions. And in order to have a much more accurate result from the LLMs, the number of dimensions that you use to encode your private data have to match the same number of dimensions that the LLM was used to train with. That is, if you choose to transform your data using vectors of 20 dimensions, then the LLM that you choose will also have to be trained with vectors of 20 dimensions. If that is not the case, then there will be a difference here, and when you try to search for the similarities, then things might not give you the correct answers. So once we come back with that data is when we inject additional data, these vectors, into the real query that is sent to the LLM, and then this is when we start to do the LLM is the one that starts to do the comparison if the data that has been encoded in one way does match the data that was trained for, and it will give you whatever answer it comes with. Now, this sounds fine and dandy if we know a little bit of math and vectors and whatnot, but I will say that we as developers, it will be very easy for us to just grab any model from those pre-existing trained models, and then grab any other encoding or embedding model. So the thing that we go on the top when we create our own vectors, we usually call these embeddings. And we may just grab whatever, and then use any parameters based on an example, and then maybe get an answer. This is where I will suggest you to pair with a data scientist, because they are the ones that will recognize that using a different embedding model will give you different results, and perhaps more accurate results. And the different parameters that you may apply during the encoding and the parsing will also give you different benefits and different results. So instead of us being just doing trial and error, which can be expensive in time, you pairing off with a data scientist will likely reduce this development experience and this loop. Also, where we're doing our own RAG, what is recommended is that you do the parsing and encoding. You do this separate from the application, because that is the place where you're going to spend most of the time doing things. If you're doing the chunking and the parsing and the embeddings while the application is running, then the queries that you're going to send are going to be much slower. That being said, the demo that I'm going to showcase is exactly that. It's going to showcase what you should not be doing in production. You can do RAG from any kind of data source. It could be just a bunch of text files. It could be a database. It could be a graph. It could be what have you. So there is a bunch of databases out there that nowadays offer vector support. If you like Postgres, there's an extension called pgvector that does this. There are dedicated databases that the only thing that they do is vectors. For example, Chroma, which is an in-memory database. But I will say that when we're talking about databases, obviously, Oracle is one of the names that come around. Turns out that the latest version of the database does support vectors, and it supports a lot of formats. So if you have access to an Oracle database, then you can use it with RAG techniques. Now, if you don't have access to an Oracle database, let me tell you, it's quite easy. There is a free version that we can use for us developers. We can use it in development, testing, and production. You can use it on Linux, Windows, and Mac. You can use it on Intel or even ARM architectures. Just download it, boom, off you go. There is a cloud version of the database called Autonomous Database that you can just sign up for free in the Oracle Cloud, and you get access to 2 instances. And if that were not to be enough, then there are also Docker images that you can use with Docker, Podman, or any other container runtime. I would recommend you to use this one. This is the one that is quite fast to start up. It starts in 10 seconds, and it takes about 900 megabytes for download. The official one takes about 3 minutes to start up, and it's 9 gigabytes download because it contains everything. So it's up to you. I would say I suggest you to try this one. these are the ones that Spring, Vertex, Hibernate, Quarkus, and every other open source technology that consumes and integrates with Oracle, they use these images for testing. Just as a corollary, if you need to talk to other databases, other versions from 11 to 21, there is a different set of images, but they're also quite fast. These two set of images are the ones that I recommend you to use with test containers. I hope that most of you here in the audience know test containers. Yes? If you have not heard about test containers, this is one of those technologies that changes your life. Kevin Wittek from Docker was here at JCON, and I don't know if he was talking about this particular set of technologies. Now he's talking also more about AI. So basically, this technology allows you to run any container for any kind of software before and after your test cases. So instead of using an in-memory database, you can use the real database. So instead of using H2 to simulate issuing queries to your production code, then you can have an Oracle database with test containers and just boom, run everything with it as is, no questions asked. You can do the same thing with MySQL, and Postgres, and Kafka, RabbitMQ, what have you, as long as you can run it on a container. Test containers offers modules for a lot of software out there. The module is basically just one dependency that you add in your build, whether it's Maven or Gradle, that doesn't matter. Once you have that dependency, you have access to a new set of dedicated containers, for which in this case, the Oracle container, you define which particular image you want to use, and then just start it. Just works. So I'm going to showcase the demo. This is a clone of the LangChain4j examples. Oh, I was fearing this. Hold on a second. If I cannot able to see this, you're not seeing my screen correctly. I need to mirror, and I don't see it. Okay, we're doing the hard way, which means you and I will be seeing the same screen from here. So these are the RAG examples from LangChain4j. I'm going to start with a simple one. You see there are two text files here. One is the, what is this? This is the Miles Over Smiles car rental services terms of use. So this is a fictional company for renting cars. And this is the biography of some random person known as John Doe. Okay. So now we look here into the first RAG example, and we're going to use those two files as an input for RAG. We're going to talk to OpenAI GPT-4 mini model, and in this line here, we're loading those documents from TXT, then performing this operation which is called chunking. We're going to cut the documents into up to a certain size in characters, and then use that particular chunk to encode it as a vector. Now, here's one of the first tricks that happens. Well, right now, this is John doing the defaults, which is going to chunk it into a particular size. There is no overlap within the chunks. There is no additional parameters here, and it's using a regular text parser, which comes baked into LangChain4j. Once that is done, we create an AI assistant that will use an in-memory a message window chat memory, so I will remember the last 10 conversations that we had with the chatbot, and then just start the conversation. So this is very simple. Let's run this, and we will be able to ask questions about John Doe and Miles of Smiles. Let's see, it starts. So I do have network. Yes, so here we go. Question: who is John Doe? She'll tell us there's a fictional character that lives in Fictionville, USA, philanthropist, blah, 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 blah. Exemplary figure, blah, blah, blah. Yeah, this kind of matches what is found in that particular file. So we can also ask, for example, what is the cancellation policy of Miles of Smiles? So obviously, ChatGPT-4 Mini that is found on live has no clue what Miles of Smiles is. So if it gives us a correct answer, it's because it was able to find the chunk and the parse documents that we sent in the beginning, which, by the way, we can see here when the application starts, it found 2 documents which were split into 5 text segments, so there are 5 chunks. And those 5 chunks were encoding into vectors and then added to our embedding store. So now they become available to the LLM. Okay, so now we do enter here. And it should tell us the cancellation policy is about 2 bullet points, I believe. And sometimes it gets confused and says that it was not explicitly stated anywhere, which is kind of weird because we're supplying the documents. So come on, the network is being a bit slow. Another enter? Yes. There we go. So I made it fail because I put 2 enters. There are the 2 bullet points. Okay, so it did work. All right, so these are the basic things. Great. So let me rerun this thing once again. And I'm going to ask questions about the model. Let's see if the latest version will get it right. So some of you may know that I'm the author of a particular project called JRelease, which allows you to release projects. So I wanted to ask it, how can I deploy artifacts to Maven Central using JRelease? And why I'm asking this question is not just because I'm an author, it's because I know exactly how this must happen. And if the LLM doesn't give me the correct answer, I will be able to tell immediately if it was an hallucination or something weird. So let's see. It's taking a while because of network. So that's one of the things that we have to contend with whenever you are talking with one of these models. Network. I mean, latency is not 0. So we have how many bullet points? 2, 2, and 1. Let's see. To deploy to artifacts, let's say, so you had to configure the project, whether you use Maven or Gradle. Okay. You install it based on this documentation, kind of okay. Then remember that it says something about Maven and Gradle, but it's telling us to use the YAML configuration. The first thing here is kind of okay, but this part, which is the important one for deploying, is completely wrong. It looks like something that could work, but let me tell you that this is definitely not going to work at all. And then says that you should use Maven clean install. This is totally wrong. As you may know, I'm one of those people that say you should be using Maven verify, not Maven clean install. If you have not heard about this, there is a set of memes about Maven clean install and Maven verify that you can simply search for Almiray and GitHub and you will find it. So again, this is wrong. And then invokes the assemble or the release commands, which actually should be deployed. So yeah, this didn't get it. How can we make this work? Well, what if we were able to supply the document? So let's stop this one here. What if we were able to supply the documentation via RAG techniques? And that will let the LLM be aware of what we're doing, right? So what I have locally, I have the set of documents, and they are in ASCII doc format. This is important. Does anyone hear what ASCII doc is? Okay, does anyone know here what Markdown is? It's a simple text format with a bit of syntax. Very, very simple. Well, ASCII doc adds more syntax to it, so it's not just simple text. So what we're doing in this case here is that in this line here, we're loading additional documents into the chunking and the parser. But we're using the default chunking and the default parser, which is text file. It does not understand the Markdown syntax nor the ASCII doctor syntax. This is important because if the default chunking is like, say, let's grab the first 500 characters of a given input file, what if that 500 limit happens to be in the middle of a section that is important? Say that section is a snippet of code. So that code will be broken down into several pieces. And thus, during the inference, it will be wrong. So we have to have a parser that understands the underlying format. So when you're supplying PDFs, be sure that you're using a PDF parser. If it's HTML, it has to be an HTML parser, and so on and so on. So someone asked me the question early on before this session is, Why isn't there a cookie cutter option for just doing RAG? Well, this is one of the reasons. You need to select the right parser for your given format. If you don't, it's very likely that you're going to get the wrong results. So I'm going to showcase something that will give us close results, but it'll be wrong because it doesn't understand the whole syntax. And that's the only change that I did for this demo. So just additional documents. I believe it will be in total plus the 2 text files. It's 395 or 92, not 97 documents. We'll see when this thing starts in just a moment. It's going to take a while, close to a minute, I think, to load all the documents. 397, yes. And it will create about 2,800 chunks, 2,500. This is the reason why you don't want to do this while the application is running. It takes time. So you do this in a batch. You do it in a nightly operation. You do it whenever the data is ready, but you don't do it while the application is running. So you will do this on a separate process and add all the embeddings and then store the embedding software. So because we are doing this thing, everything in memory, we cannot do that secondary batch process. Okay, so we're ready. We can ask the same question before, who is John Doe? It should answer correctly because we are still supplying the initial text files. So who is John Doe? And she'll say something about that fictional character from Fiction Bill and blah, 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 blah. Yep, still there. So that's good. What is the cancellation policy of smiles? Sometimes the LLM will get it wrong again. Last time we got it right. We got 2 bullet points. Again, we got 2 bullet points. But if you recall, even though we got 2 bullet points, I can guarantee you that this tokens, this answer, even though semantically similar, is not syntactically equivalent. It doesn't use the same words. It doesn't use the same tokens, which brings us to the next problem when building these kind of applications. If we want to assert the output of an LLM, which are by their own nature non-deterministic, how can we ensure, how we can have a green test if we want to do a simple, perhaps a simple regex comparison or a character by character comparison? The LLM most of the times won't give us the same answer bit by bit. So we need other techniques in order to ensure that what was returned from the LLM is accurate up to a certain point, but we cannot do the word-by-word match operation in this case. So be very aware of this. We don't have yet an answer for this. So, but because there are so many people working on these problems, there's bound to be something quite soon. So now let's ask the last question, which is, how can I deploy artifacts to Maven Central using JRelease? And this should give us a different result because we are providing a whole set of documents. Let's see. It's taking a while. It's kind of weird. Perhaps if I was running the model locally, it would be a bit faster. Yes, we notice that we have a different answer now. Let's see, we have like 3 bullet points or so. It says something like, yeah, you need some environmental variables. Those things did not appear before. Those variables are accurate. Then you configure a build using Maven in this case. Yeah, that's correct. Then for Gradle, use something else. This doesn't make sense at all. On the YAML configuration, yeah, no, nothing. And the deploy step, like, yeah. So this tells me that even though I was able to read the actual documentation, it's because the syntax of ASCII-Doc was not understood by the parser. I'm getting a bogus answer. And this chunk of XML is coming from the guide as I expected, but it has to do something that is completely different for the matter that I want to do, which is deployment. So this is wrong again. So watch out for these kind of things. Now the last thing is, when I showcase running this demo, it took us what, like almost a minute for all these documents to be chunked and parsed and do the embeddings? Well, this is where if you use a vector database, then we can make things faster. In order to use this demo, I'm going to showcase a few things that I don't recommend you to do in production. This is for demo purposes. We're doing the parsing and the chunking here. Do it in another process. And I'm going to showcase every single bit of components to make this work. In the previous example, it was just, trust me, this works. Now I'm going to showcase every single little bit. So, first, let's skip this one first. We're using the model right there, just as before. We are going to use a simple text document parser. This is where you will choose PDF, HTML, or something else. Then we load all the documents. In this case, will be, for now, only the miles of a smiles document. We're not going to ask about JRealizer in this case. Then, we're going to use a default splitter that will create chunks out of 300 characters. And there is no overlap in between the different chunks. That is that I could have the first 300 characters and the next chunk start with the last 20 characters, so in case I have some sort of redundancy. We'll look in a moment how we're going to talk to that particular vector data store in a moment, but we continue with, this is the model that we're going to use to create the embeddings. And remember, this is the one that has to match the same number of dimensions in the model that we're going to use for asking the questions. We can choose any other model, but if it doesn't match the dimensions, we will get the wrong answers. Then we have access to that embedding store where we're going to retrieve our custom vectors. That embedding store makes use of the data source that we'll see in a moment how we configure this. And then we go into the content retriever. This is the one that grabs the data from your data sources, from your embeddings, and will combine it with your prompt and your query so that it goes into the LLM. These parameters here are the ones that again, we can play with this all day long, but a data scientist will tell us much better, you should use a 4 there instead of a 2, for example. I have no idea about these parameters, so that's why it's easy for me to say numbers. Then we create the chat memory, and then we assemble the whole thing by passing the model, the content retriever that has access to our embeddings, and then the chat memory, and we're done. So the last question is, where do we get our embeddings? From where? Where is our vector data store? I could have been running the database on containers or natively on my machine, but in this case, I'm going to do again something that I don't recommend you to do in production, which is I'm going to use test containers to start a brand new database every time I run the application using this particular image. This is the latest image. Oracle 23 AI update 8 was released 2 days or 3 days ago. So this image will be updated quite soon, probably this weekend, with these particular settings. And once we start the container, I just simply grab that in the data source, and boom, just return a regular Java SQL data source. It's as easy as that. You don't do this, you talk to an actual database already running somewhere on a cluster or what have you. Okay, so in order for this to work, I made some changes to the build configuration. So we need, let's see, we need the latest version of the JDC driver. This is how LangChain4j uses this particular managed version of the property. You want to use that, or you explicitly define the version, it's up to you. So there's LangChain4j, different modules. We need, let's see, going down. The demo still uses H2, but I'm not using it. So here is the module for LangChain4j. The only reason I'm using this exclusion is because this module uses the older version of the driver, OJDBC 8, but I want to use OJDBC 11. So just regular Maven configuration. There's nothing strange about this one. And then I have also the connection pool and the test containers module for Oracle so that I can start my, database instance using test containers. All right? So with that, we're almost running out of time. So I want to have time for some questions. So we'll run this. And again, it's going to take some time to start the application, to start the database, do the chunking, and then do the storage. That's fine. Trust me. Here is the database is ready to use, and this particular set. So it starts pretty quickly, and the embedding is ready. So remember, I'm not supplying the biography of John Doe. So if I ask that question, who is John Doe? It should give me something completely different. Like John Doe is a typical placeholder for an unknown person, something like that, instead of John Doe that used to live in Fictionville. Okay? So what is the cancellation policy of Miles of Smiles? So now these embeddings should be retrieved from the Oracle database, from that vector database. And then it says something weird like that. Hey, I know that I'm supplying that data, but it was unable to find it. It could do something like this. Yet it is found in the source code. So the whole point of this demo is to showcase there's a bunch of different components that you can micromanage and tweak to your hard content, and that you can connect that to any vector database. So I'd love if you were to use Oracle, but there are many other options out there if you want to use them. Whether you want to use test containers in this way or not is something else. All right, so we go back to the slides. When I was preparing the slides, this was back in February, this particular article came out that vector databases are here to stay. And by the way, that guy is Gerald Benzel. He's the guy that has created the images that I told you before. He's my manager. You might also be aware of MCP, which is also the latest rage. It started in November of last year. How many months since? About 7. This is quite recent. When I took this screenshot, this was February 12th. In February 14, Spring AI version 1.0.0 milestone candidate 6 was announced. And that same day, MCP.io announced that Spring AI will become the reference Java SDK. So if you were to look at this URL nowadays, you will see a new entry on the left side saying Java SDK, and that happens to be Spring AI. It's been evolving so fast. There's another project out there called NCP Servers. It's implemented using Quarkus and JBank, but you don't have to use those technologies. It's just how they can run. And since then, there have been many more MCP clients and MCP servers that allow you to supply additional data to the LLMs with also additional capabilities, such do you want to read all the data from a Git repository and enact operations on the Git repository on your behalf? You can do so. So there are discussions on MCP server where this is the right thing to do, where is the security model when you enable additional tools for an LLM to be able to act on your behalf. What's coming next? I have no clue. This environment is changing very fast. NCP did not exist 7 months ago. Now everybody's talking about NCP. RAG is not going away, but more people are just trying to experiment what is going on with NCP. Is there something better than NCP coming up in a few months? Likely. I don't know the name, but it's bound to happen. So we are right now at this position. We are at crossroads. The advancements that AI can provide to our line of work, to our industry, to our lives, to humanity are undeniable. It's up to us to decide how we're going to use it. AI tools are not going away. They are also not taking your job away. But someone that knows how to use AI properly might likely take your job away. I have a few resources for you. So the first one is it's a website that has a lot of information about free tools that Oracle offers for developers, all kind of things. The second one is signing up for the free cloud version, so you don't get charged on your credit card. The third one is where you can download the free version of the Oracle database. And the fourth one is where you can see different workshops and tutorials that allow you to run Oracle technologies and non-Oracle technologies as well. Okay, so I think we barely have time for questions. I'm going to go into Slido. Can the local resources be easily changed upon LLM's decision, that is providing neurodated data about the company or the persons via prompt? It depends on you. So if you get an answer for the LLM and you want that answer to be available to subsequent questions, you have two options, whether you make this part of the chat memory, and once you finish this application, then that information is gone. But if you want to persist it, then you will have to grab that data, go through the chunking and embedding process, and then store it in your vector data store. This is a valid use case, but you have to be aware of that performing the chunking and the processing will take additional time, so offload it. Are there any tools and libraries that can help with processing only the new change deleted documents when storing in vector store? Not that I'm aware of, but given that this is bound to be something common, I guess there will be someone that will offer ready-made components that will allow you to do this processing much easier. What color do you want the AI to be? I don't know, in my mind it's blue. Are these vector database queryable like regular databases? Yes, so all these vector databases will store vectors in a new data type. Some of them will be just an array of numbers. In the case of Oracle, it's a new completed data type, and we can do queries, we can do simulatory searches, you can even index vectors. So I would recommend you to have a look at the documentation of your vector database vendor of choice to see which options they offer. How many in the audience are using LangChain4j? Let's see some hands. Just a couple of hands, okay? And someone is using Oracle 23 AI, thank you, and Spring AI. What kind of embedding model use 23 for the vector search? It's up to you. You are the one that defines the vector embedding model. It's not the database. The database simply says, boom, there you go. Although, there are services in the Oracle Cloud that offer RAG, so they will have some predefined models for you. But again, I will recommend you to consult the documentation for that particular feature that you want to use. RAG works with local LMS, but for NCP, the models should be compatible with NCP tools. Is this statement correct? So RAG works for local and remote LLMs. It doesn't matter where the LLM is. And the NCP models also work for any kind of model, whether it's local or remote. The thing is that you may be the one running the MCP server, or you may be connecting to the NCP server provided by a third party. And then it's a matter of, do you trust that code? Because from the point of view of the element, that NCP server becomes an opaque object. It's a black box. You have no clue what this thing is doing. So with that, I thank you very much for your time. You have been an awesome audience, and enjoy the last sessions of JCON.